Hello everyone, welcome to this educational video. My name is Yogesh Kumar and today I'll be presenting a detailed look at interrupt-driven input-output and concurrent input-output. It is a very important topic for our operating system. Input-output management is the cornerstone of every operating system. This presentation explores how modern system manages input-output efficiently using methods like input interrupt-driven, concurrent. These techniques help reduce system idle time, improve responsiveness, and ensure smooth performance in multitasking. Now, input out, input output act as a bridge between a computer's internal processes and the external devices like keyboard, mouse, hard disk, etc. Without proper input output handling, the CPU would waste a lot of time waiting for data to be read or written. That's why managing input output efficiently is so important. Operating system must coordinate multiple hardware and software processes. Efficient input-output plays a critical role in this coordination, especially in systems that serve multiple users or real-time applications. If the input-output system is slow or poorly designed, then even the fastest CPU can't save the system from becoming a sluggish. There are three main types of input-output techniques: programmed, interrupt-driven, and direct memory access. Programmed I/O involves the CPU checking the device constantly. Interrupt-driven I/O lets devices from the CPU when they are ready. DMA allows devices to talk directly to memory. In this video, we will focus more on the interrupt or and concurrent techniques. Let's start with interrupt-driven input-output. This method allows the device to send an interrupt signal to the CPU when it's ready for data transfer. It's much more efficient than programmed input I/O because the CPU doesn't have to waste time checking the device. It can do other work and respond only when needed. Think about typing on a keyboard or moving a mouse. Every key press on or moving triggers an interrupt. The CPU stops what it's doing briefly, processes the input, and gets back to what it was doing. This kind of real-time responsiveness is only possible through interrupt-driven I/O. The biggest advantage here is efficiency. The CPU can perform other tasks while waiting for I/O to complete, which improves overall system throughput. This method also reduces idle time and enhances system's ability to handle multiple tasks concurrently. Now, let's break down how it works. First, the device sends an interrupt-driven ready. Second, the CPU pauses its current work and saves its state. Third, it jumps to the routine called the interrupt service routine or ISR. Fourth, the ISR handles data transfer between device and memory. And at last, it's done, the CPU restores its previous state and resumes the task. It's like pausing a YouTube video to answer a call and then resuming where you left off. Our next topic is concurrent input output. This method allows multiple input-output operations to happen simultaneously. It's extreme useful is it is extremely useful in multitasking and multi-thread environment, where we don't want one input-output process to block others. This improves system throughput and reduce wait times. Concurrent input-output allows program to continue executing even after initiating an input-output operation. It significantly improves the resource utilization and avoid bottlenecks and supports real-time processing. For systems like servers or media players, concurrent input-output is essential. There are three primary methods: multi-threading, which multiplies threads that can perform input-output without affecting each other. Second, message passing, which is used for communication between processes without shared memory. Third, asynchronous input-output, where the process is notified once the input-output is done without blocking the execution. When comparing techniques, programmed input-output is simple but inefficient, where interrupt-driven input-output is better than programmed and, and better in terms of responsiveness, whereas concurrent input-output is the most advanced but complex. So, choosing the right method depends on system needs, complexity, and performance goals. But with great power comes the great responsibility, and these techniques bring challenges like latency due to frequent interrupts, complexity in managing concurrent operation, error handling, especially in concurrent environments, which requires careful design. Now you see interrupt-driven versus and concurrent input-output in action everywhere, where operating systems rely on them for multitasking. Networking uses concurrent input-output to handle multiple connections, and multimedia applications use them to stream audio, video without lag. In summary, both interrupt-driven and concurrent input-output are crucial for efficient system performance. As system grows more complex, mastering these techniques help developers to build faster, more responsive applications. Further, operating systems will rely even more on such methods to handle increasing demands. At last, I would like to sincerely thank Ronak sir for his constant support and my classmates for their collaboration and encouragement during the project. Thank you.